Today we are going to take a look at DAU Investigation 3.3, which is about the mean absolute deviation. So the question today is, what information does the mean absolute deviation, or MAD, provide about how data vary in a distribution? This lesson starts on page 67 in your text. Now, the mean absolute deviation can be described in many different ways, but the best way to describe the mean absolute deviation is simply the average distance of all values in a set from the mean of the distribution, which means we're looking for the distance every number in our information is away from the mean of the set. So we're going to go on here and we are going to look at wait times. Wait times at an amusement park. So Sally and her family spent the day at an amusement park. At the end of the day, Sally noticed the sign below. Amusement park wait times. Average wait times for attractions: 25 minutes for the carousel, 40 minutes for rock climbing, 15 minutes for the roller coaster, 25 minutes for the scenic trolley, 18 minutes for the alpine slide, 10 minutes for bumper cars, 15 minutes for Ferris wheel, 60 minutes for spinning swings, and 22 minutes for the zip line. And then there's some questions that said which ride has the shortest average wait time. Well, by looking at this information, we can tell that bumper cars has the shortest average wait time. And the longest would be the spinning swings at 60 minutes. Now, Sally waited in line longer than 25 minutes for the scenic trolley ride. How could this have happened? So if we take a look up here for the scenic trolley ride, we see that the average time is 25 minutes. So if she waited longer than 25, then her point of waiting, or her data point in that set of data to find the mean for the average wait time for the trolley, would be on the upper end of the information. Since it says average, we are looking at the mean time that it took to wait to get from the line to the ride. So we are going to take a look at question A today. Question A says, since Sally waited in line longer than the average wait time, she wondered how much wait times actually vary. So the dot plot below shows the distribution of 10 wait times for the scenic trolley ride. Notice how one person only had to wait 10 minutes, while there was one person that waited 40 minutes. So there is a range of 30 here, 30 minutes of time between the shortest ride and the longest ride time. Now, since Sally says that the mean is 25 minutes, we have to figure out if she is correct. So the first thing we're going to do is we are going to add up all of the values and actually find the mean of this time. So we're going to start by adding up the times here. So we're going to take and we're going to say that there's a dot at 10, so 10, and then there's a dot halfway between 14 and 16, that would be 15, one at 20, 2 at 22, so we could go 22 plus 22, 1 at 25, 1 at 30, 1 at 31, 1 at 35, and 1 at 40. So we're going to take up and we're going to add that information. So do that right now. So the total of the wait times equals 250 minutes. Now, in order to find the mean, we need to figure out the number of entry points. So we're going to count the number of dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 different dots. So we're going to take 250, divide it by 10, and our mean is 25 minutes. Is the mean of this data. Okay, so we can agree that if we add all of these up and divide by how many there are, we get a mean wait time of 25 minutes as well. So, going on, we're going to take a look at A2 now. Sally wonders how typical a wait time of 25 minutes is. And she says, I can find how much, on average, the data values vary from the mean time of 25 minutes. And she uses the graph below to find the distance of each data is away from the mean. Now, what she's doing by doing this is she's finding the average, the distribution or the deviation away from the mean. So this point here at 9, or I guess 10 here, this would be 10, is 15 points away from the mean, okay? Or it has a distance of 15. This one up here at 40 has a distance of 15 as well. So what we're going to do here is we're going to add up the distance each number is from 25, because our mean is 25, okay? So the mean is 25. And we are going to add them up and actually find the mean of that. So the mean absolute deviation is simply the mean of the distance away from each number. So Fred says he made an ordered value bar graph to show this, to show the same idea. Either way is correct, it's showing the same information. And now it says describe how you can use each graph to find how much on average the data values vary from the mean time of 25 minutes. So this is simply asking us to find the mean absolute deviation, or the mean deviation, the mean of how far each number is away. So what we're going to do here for 2a, so this should be a, 2a, is we're going to take and we're going to add those numbers. So that would be 15, 10, 5, so 10, 15, 5. There are 2 3s, so 3 and 3, a 0. Okay, we have to take that into account because actually one of our points was there. A 5 and a 6. Okay, a 10 and another 15. So 10 and 15. And now we're going to add that up. Okay, and so the total time there is, that's 25. Those would be 13, 11, 25, 50, 61, 74. So the total of this is 74 minutes of deviation. All right, so now we're going to find the average. So we're going to count the number of minutes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10, again, 10. So our mean absolute deviation is going to be the distance, total distance, each number is away, so the total distance was 74 minutes. This was the deviation total, T-I-O-N, total. And then we are going to divide that number by 10, because that's the number of data points. Okay, and when I take 74 and divide it by 10, I get a mean absolute deviation of 7.4 minutes. Which means that every person, even though the average is 25 minutes, that the average person could expect to wait about 7.5 minutes longer or shorter on average than the actual wait time. So that wait time of 25 minutes, the average wait time of 25 minutes back on this page, whoops, get rid of that. Back on this page, where it says that the average wait time for the scenic trolley was 25 minutes, we can figure that we're going to wait about 25 minutes, but in reality, since we have a mean absolute deviation of 7.4, we could wait anywhere, realistically, from about 17.6 minutes to adding this on to the other end of this, that would be 32.4 minutes. Okay, so realistically, our wait time is going to be somewhere between these more often than not, although 25 is the mean for the set. So this is the mean absolute deviation, which means our actual wait time could deviate from the mean up to an average time of 7.4. So realistically, if I stand in line for the trolley, I know I should be at the shortest time on average is going to be about 17.6 minutes, and at the longest on average time is going to be about 32.4 minutes. All right, so moving right along, we are going to continue with question A to B. Question A to B asks, what does this information tell you about how long you might have to wait in line to ride the scenic trolley? Well, since the mean time is 25 minutes, and my absolute deviation, or my mean absolute deviation, my MAD is 7.4 minutes, then that tells me that exactly what I just summarized on the other page, that I'm going to have an average wait time of anywhere from 17 to about 32 minutes. Okay, that this is going to be what's typical. So typical. Now, that when I use the word typical, that is a very long range. Okay, we can say that even though it typically, the average is 25 minutes, that typically you are going to wait somewhere between 17 and 32 minutes, that is not a very close distribution. If we go back and we look at the line plot for that information, okay, and I'm going to clear off these dots here real quick. If I look at just the dots, okay, and I'm going to color those in blue real quick for you. Okay, if I look at those dots, they are very spread out. They go from 10 all the way to 40. So we have a range of 30 with a mean absolute deviation of 7.4. This is a very large distribution. Maybe not as large as other things could be, but this data is not clustered close together. So that is exactly what the mean absolute deviation confirms. Is if we had a range of 30, we only have 10 numbers, they are very spread out. So this also tells me that our data is very spread out. All right. So we're not going to do C. And if we go on into below there, it says that Sally and Fred calculated a statistic called the mean absolute deviation, or MAD, of the distribution. It is the average distance or mean distance from the mean for all values. I would definitely make sure that you understand this. And what that means is once we find the mean, we're going to find the distance away from the mean and then find the mean of that. So you're actually finding the mean twice. Kind of like when we found the interquartile range, we found the median to divide our set in half, then we found a lower quartile, which was the median of the lowest half, and the upper quartile, which was the median of the upper half. I would take maybe a few minutes right now and look at B and see if you can complete B before coming to class. But definitely try to have B1 and part of B2 before class. All right. If you have any questions, don't hesitate to ask. We'll see you all in class.